Hi class, today we're learning about solving rational equations. So let's just get the beginning of this note filled out here. So let's just remember to solve an equation means to find the values of x that satisfy that equation. And because we're dealing with basically fraction functions, we have a numerator and a denominator, we have to remind ourselves of these rules, okay? So if you're multiplying fractions, then you just multiply the numerators and multiply the denominators. If you're dividing fractions, then the rule is you flip and multiply. So it becomes a over b times d over c. If you're adding though, or subtracting, you need a common denominator. So in this case, a over b plus c over d has a common denominator of bd. Okay, so that means that a has to be multiplied by d, c has to be multiplied by b, and you can write it just as one fraction with the addition on top because now they have the same denominator. So that will help you guys out. Okay, so in order to find common denominators, it's going to be best to factor the numerator and the denominator first if they can be. Okay, so we start with this example. We're actually going to do these two examples first. Notice what they have in common is it's just a rational expression equaling a number, and then a rational expression equaling a rational expression. Whereas in these cases down here, we have addition. So that's where it becomes a lot different. So when you have this where it's just rational equals number or rational equals rational, you can cross multiply. So when you cross multiply here, you actually just end up with x minus 2 equals 0. So x equals 2 is the solution to that equation. And notice if you put 2 back into the function, you will get left side equals right side. In this case, we need to cross multiply. So this will just become x plus 3 times x plus 2 equals x minus 1 times x minus 4. So now we just need to FOIL out and solve. Okay, so this is actually a quadratic equaling a quadratic, which we've been doing since grade 10. So this is x squared plus 5x plus 6 equals x squared minus 5x plus 4. So the x squareds cancel out, and we end up with a 10x on this side equals a negative 2 on this side. So x equals minus a fifth once we rearrange. So if we go to GeoGebra, you can see what this would look like graphically. So on the left side, we have the function x plus 3, x minus 4. That's what that looks like. Okay, and on the right side, we have the function x minus 1 over x plus 2. That's what that would look like. Notice that they only have one point of intersection right there. Okay, because of the asymptotes, they don't actually intersect anywhere else. So if you zoom in, you can see that that point of intersection is when x is equal to minus 1/5, which is minus 0.2. So that matches what we did algebraically. Okay, now we get into these problems where we're actually adding or subtracting different rational functions, which means we need to get a common denominator. So in this case, the common denominator is you just multiply the denominators together. So it's just x times x plus 4. So that means that 3 has to get multiplied by x plus 4, and 2 has to get multiplied by x, and then we have our common denominator of x and x plus 4 equals 10. Okay, so now we just need to simplify this, and then it will become just the same as the questions we already did. So we get 3x plus 12 plus 2x over x squared plus 4x equals 10. So I'm going to do two things at once now. I'm going to cross multiply this up, and I'm going to simplify this. Okay, so you get 5x plus 12 equals 10x squared plus 40x. Okay, and now this is again just a quadratic equation. So I'm going to move everything over to this side. So I would get 10x squared plus 35x minus 12 equals 0. Okay, so now you can either factor or use quadratic formula to solve that problem. Okay, this question here, we have a common denominator. We're just going to simplify the left side. The right side, we don't need a common denominator because there's just the one number. So we have a common denominator of x and x minus 8. Okay, so one gets multiplied by x minus 8, and then this one gets multiplied by x over the common denominator x minus 8 equals 1 over 32. Okay, so we get 2x minus 8 over x squared minus 8x equals 1 over 32. Okay, so now we cross multiply and solve. So 2 times 32 is 64x minus, gotta get my calculator here, 8 times 32 is 256 equals x squared minus 8x. Okay, so you can rearrange and solve for this. Okay, you'll get x squared. I'm behind my head now, aren't I? So basically you just need to rearrange that like I did here, and then you'll factor or use quadratic formula to find your final solutions. Okay, so now I want to get into these word problems because they are rather difficult and they kind of require a different style of thinking. So if you want another resource to solve example 2, you can go to page 278 in your textbook, and they actually work through the solution. It's all written out. So if you prefer written explanations, that might help you. Okay, so when they work together, Stuart and Lucy can deliver all flyers in 42 minutes. When Lucy works alone, she finishes deliveries in 13 minutes less than Stuart when he works alone. How long does Stuart take to deliver flyers when he works alone? No, we cannot compare the total flyers they deliver. What can we compare? So I like to break out this information because it's very confusing and you might be thinking, how does this turn into a rational equation? And it will. So what are our variables? Okay, what are the unknowns? So we don't know how much time it takes them to deliver the flyers, and that's what we want to know. It says, how long does Stuart take? So we're going to say let S represent minutes it takes Stuart when working alone. Okay, and you know what? Because I'm having some technical difficulties, I'm just going to make the decision. I'm going to do these word problems on a separate video. So go ahead, you guys can use this video just for the basic solving, and I will do the word problems on a separate video. So thanks for watching. Hope you learned something.